A clock pendulum. When a point mass has a weightless, inextensible, and perfectly flexible string that is suspended from rigid support, then such an arrangement is known as a simple pendulum. If we slightly displace the point mass to one side and release it, then in such circumstances, the simple pendulum starts swinging to and fro from its mean position. This swinging of a simple pendulum in a straight line from its mean position is an example of simple harmonic motion. Oscillation of guitar strings. A musical instrument like guitar strings is an example of simple harmonic motion. When we twang a guitar string, the string starts moving to and fro. First, strings of guitar move forward and then move in the opposite direction. This motion causes vibration. These vibration created by guitar strings create sound waves that human ears hear as music. Car suspension. A car suspension system contains springs. As the springs have elasticity property, whenever there is any bump the spring compresses, which results in rising of car's wheels without actual rising the car body. Similarly, when springs expand it causes the wheel to drop without the actual dropping of car body. This causes to and fro motion, which is simple harmonic motion. Although this type of motion is damping, which means it reduces over a period of time. This simple harmonic motion reduces the shock which passengers receive when a car goes across a bump. Hearing. It is due to simple harmonic motion that living organism has the ability to hear. When the vibrating molecules come upon our eardrums, it causes our eardrums to wobble. These vibrations caused in our eardrums are passed to organisms. Brains. In due course, these details are transmitted to the organism's brain through auditory nerves. The brain then translates these vibrations into apprehensible sounds. Bungee jumping. Simple harmonic motion examples can also be seen in our sports, for example, bungee jumping. In an adventurous sport like bungee jumping, a long recoiling cable is tied up to the person's legs. Then person performs bungee jumping jumps from a particular platform situated at height. When the person jumps off the cliff, due to the recoiling cable, he is pulled back and again moves down due to gravity. This keeps on going. As a repetitive to and fro motion can be seen in bungee jumping, it is an example of simple harmonic motion. Swing. Swings can easily be seen in amusement parks, gardens, schools, etc. The motion shown in swings is known as simple harmonic motion because while swinging, the child sitting on it experiences the force acting upon it, which is directly proportional to its displacement and directed towards the equilibrium position. This causes the back and forth, repetitive motion of the swing, causing simple harmonic motion. Newton's cradle. Simple harmonic motion can be seen in Newton's cradle. This is an apparatus that shows the principle of conservation of momentum and the principle of conservation of energy. Newton's cradle consists of 5 metal balls suspended by string, so that the movement of spheres is in one place. All balls are placed so that all orbs are at rest and all balls are in contact with the adjacent ball. In Newton's cradle, when the endmost sphere is taken from rest and pulled and released, the sphere starts swinging like a pendulum, and the released sphere hits the adjacent ball. When the adjoining sphere comes in contact with the released sphere, the energy and momentum from the released ball are transmitted through the 3 balls at rest to the final ball on the other endmost sphere. The transfer of energy and momentum causes the ball to be in motion with the same speed as the first ball. If more than one sphere is pulled up and released, then the same number of balls, as much released, will be set in motion from the end of the resting spheres. Here we can see oscillation of the balls to and fro. They are showing simple harmonic motion. Motion of a body in a hole drilled through the center of the earth. Imagine if we have a tunnel through the earth's center and a body having some mass released inside it. then due to gravitational attraction force, which acts upon the body, moves towards the Earth's center. Here the body will never fall to another side of the whole of the Earth due to variation in the gravitation constant g, which is maximum at the surface and zero at the center of the Earth. When the body falls toward the center of the Earth, it only reaches the center, then again gravitational pull is exerted on it, due to which moves back again in the opposite direction. This process keeps on going. This periodic motion of the body inside the Earth hole is a simple harmonic motion. However, this is a theoretical example of simple harmonic motion. Mass loaded on springs. When a mass is suspended from the lower end of the springs, then due to its weight, the length of the spring is increased. Due to the elasticity of springs, it exerts a restoring force, due to which it moves again in the opposite direction. When we pull, the mass is suspended slightly downward and released. Then it oscillates up and down along with loaded mass, which is an example of simple harmonic motion. Oscillation of block in liquid. Oscillation of block in liquid is also an example of simple harmonic motion. When the block is pushed down a little into the liquid and left, it begins to oscillate up and down in the liquid, showing simple harmonic motion. Torsion pendulum. The torsion pendulum is an example of angular simple harmonic motion. A torsion pendulum consists of a disc that is suspended by a thin wire. When it is twisted and released, it moves back and forth direction, executing simple harmonic motion. A torsion pendulum rotates in place of the swing. Such types of pendulums are used in a mechanical wristwatch. Oscillation of a ball in an air chamber. A ball in an air chamber having a long neck also shows simple harmonic motion. Suppose we consider a ball in the neck of an air chamber having air pressure in it. The air pressure in the container is atmospheric. If we slightly push down the ball in the neck of the air chamber, the ball will start oscillating up and down, showing simple harmonic motion. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.